So looking at these angles, Y was probably the easiest one, right? Because they're vertical angles. So vertical angles are always congruent, all the time, every time, no matter what. So that's why Y is 93. Let's look at W. W is a linear pair with 89. So to find W, all we had to do was 180 minus 89. So that's where this came from. Because we know that linear pairs are always supplementary. And then, let's see, Z was a linear pair with 93. Z was a linear pair with 93. So 180 minus 93 will get us Z. So the toughest one to find was actually X. By no means was it very tough. We know that W was 91, right? 91. And these are vertical angles. So you could have said 17x minus 11 equals 91. And then add 11 and divide by 17. If you didn't work it that way, if you didn't get W first, then you would have said 17x minus 11 plus 89 equals 180, right? Okay, let's check our homework. It was called complementary and supplementary angles. Complementary and supplementary angles. All right, so I'm going to work number 7. Are there any others that you needed me to work? Okay, that's fine. That was just a bonus one that I worked then. So I'm working number 7. Anything else, guys? This is your chance to ask. Okay, let's get started. 7, 8, and 14. So get your worksheet on in front of you. 7, BXD is 4x minus 50. And GXE is 2x plus 10. What's the vocab word? The vocab word for those angles, vertical angles. Vertical angles, I made you write this on your notes, are always congruent. Every time, always congruent. So congruent means I can set them equal. 4x minus 50 equals 2x plus 10. 2x equals 60. X is 30. But sometimes on these problems, solving for x isn't the tough part. It's finding the angles we ask you to find sometimes. So let's see. If x is 30, let's plug that in. 4 times 30 minus 50. 70. So that means that these angles we just solved, these angles are 70-degree angles. 70 and 70. It's asking for BXG. BXG. That would be the supplement of 70, right? Because those are a linear pair. So 180 minus 70 is 110. And then DXE, oh, those are vertical angles. So 110. That's why they're both 110. It's CAL, vertical. Okay, anyways. Ready? Number 8. AXG is 3x. And GXF is 2x minus 10. What we're not going to do is set these equal because we didn't see the word congruent and we didn't see the word bisector anywhere. So, but what we do know is that they put a 90-degree angle marking there. So we know that these two angles are not congruent, but complementary. We know they're complementary. So we're going to add them to equal 90. 5x minus 10 equals 90. 5x equals 100. X is 20. Like I said, we're not really done when we solve for x. Let's see, AXG. Well, that's easy. We just plug it in. 3 times 20. So there's the first one. CXD. That's this angle right here. So when you don't know what an angle is and it's not marked with anything, look for what angles could give you clues. For example, the angle that's vertical to CXD. If this one's 60, then this one's 90 minus 60. This one has to be 30. And those are vertical angles, therefore it's 30. So vertical angles are helping us out a lot today. Okay, so that's where those came from. And finally, number 14. Determine whether the statement is always, sometimes, or never true. Two angles in a linear pair are adjacent angles. Two angles in a linear pair are adjacent angles. So we talked about that a while yesterday. We talked about how this angle and this angle, this could be 150 and this could be 30. We talked about how those are supplementary, but they're not adjacent, so they're not a linear pair. If you go and you look at the definition, go to your vocab sheet and look at the definition for linear pair. To be a linear pair, two things have to happen. You have two requirements, two prerequisites. You have to be supplementary and you have to be adjacent. Those things have to be checked off to be promoted to a linear pair, to get that title. You have to have those qualifications. So, of course, they're always going to be adjacent because that's in the definition. They have to be adjacent. So today, we get a whole nother day where all we do is talk vocab. Usually in a unit, you only get one easy breezy vocab day, but today we get two. Today is our second vocab day of the unit. We're going to learn a lot of words today. These words are not going to make much sense until Monday when we tell you what they actually mean. Okay, old news, but this is the first word on your vocab sheet. So make sure you have your vocab sheet. The first word, we already know this. It goes right here. Parallel lines. Lines in the same plane that don't intersect. We love symbols in math. We love them. When two segments are congruent, we put tick marks. When two arcs are congruent, when two angles are congruent, we put arcs. When an angle measures 90, we put a box. All of these symbols. Parallel lines also have their own symbol. Let me show you two different ways you might see it. If I want to communicate to you that line M is parallel to line N, you can do this. You just put arrows somewhere on the line. Now these are not the arrows at the beginning and the end. They have to be somewhere in between on the line. Or sometimes you'll see them bold arrows like this. You'll see it like that. That is how we show that two lines are parallel. And you'll see it both ways, so I wanted you to see it. So if two lines are parallel, you add arrows to them. Instead of adding tick marks or adding arcs, you add arrows. That's how you show to someone else that they're parallel. I already said that. Okay. The next word on your list, the very next word, is transversal. Transversal, write it down. A transversal is simply a line that intersects other lines. A line that intersects other lines. It has to intersect two or more lines to be a transversal. It goes through multiple universes. So like this line, A and B, B would not be a transversal because it's not intersecting two or more lines. Trans is across. It goes across the universe. There you go. It goes across the universe. Okay. Here's a real world picture of kind of like a transversal. Although, don't you think that if those are planes and those are like the jet streams, those are probably in two different planes? Like these are probably here and the other one's probably here. They're probably not actually intersecting. The transversal does have to actually intersect. But anyways. Okay, how many angles are formed when a transversal passes through two lines? How many angles are formed? Oh, y'all are too quick. You didn't even have to think of it. All right, very good. 1, 2, 3, 4, 5, whoa, that's on a 6, 7, and 8. 8 angles are formed. So we're going to be talking about all these angles, and we're going to talk about how they relate to each other. Can't talk about how these angles are related unless we give them names. So we get to spend all of today giving them names. All right, here's how we're going to give them names. We're going to give them names based on their position. Based on their position. So we've got 2 lines and we've got a transversal. That's what we're going to have in every picture. Okay? Are angles 1 and 2 on the same side or on different sides of the transversal? By the way, that is the transversal, okay? It's the one labeled T. So they're on the same side, right? They're both on the right of T. So same side, so that's important. Are angles 1 and 2 inside or outside of line R and S? So here's lines R and S. Pretend like I were to connect them and make like a house, like that. Would angles 1 and 2 be inside or outside of the house? Inside. So we just named those angles. We did. The name of those angles is same side interior angles. So write it down. Same side interior angles is their official name. So what you need to do on your notes page is you need to write that, and then you need to mark your picture because your picture's empty right now. If you don't mark your picture, you won't know which angles you meant. So you're writing the word same side interior, and then on your picture, you're adding a 1 and a 2 to show that that's the position of same side interior. Okay, next one. Ooh, what did I change? I changed the numbers. They're not 1 and 2, they're 3 and 4. So here's our transversal. Do you agree that they're still interior? They're still inside the lines. So they're still interior. But now we can't call them same side anymore because they're on different sides. Oh, Eric knows it already. They're on alternate sides of the transversal. So that is the next word, alternate interior angles. Please write the word and add the numbers to your picture. Write the word and the numbers. Why do we need this? Okay, Eric, so we're going to learn all these names. Then we're going to learn that, well, I don't want to give it away, but we're going to learn a relationship about all these angles. And these angles show up a lot in the real world. And I promise people use this in the real world. And once you know the relationship between these angles, then I will tell you how they apply. Okay? The next one, we're going to take a break from alternate and interior and same side and all of that. This word is kind of different. It doesn't fit the formula of the other ones. This word is corresponding. It means having or participating in the same relationship. That's the definition of it in the dictionary, I guess. So, corresponding angles are ones that participate in the same relationship. They have the same position. So notice, angle 5 is to the left of T and it's above S. Angle 6 is to the left of T and it's above R. So angle 5 is to the left and above, and angle 6 is to the left and above. And so they get their own name. Their own name is corresponding angles. So that's the next one on your sheet. They lie on the same side of the transversal in corresponding positions. Angle 5 and angle 6 are called corresponding angles. Now we'll get back to the formula that we were using. The next one is same side exterior angles. Because you notice what I changed? On this one, if I draw my quote-unquote house, if I connect my lines, 7 and 8 are now outside. So they're exterior. They're the opposite of interior. They're exterior. So same side exterior angles. Angle 7 and angle 8. So write the word, mark your picture. Can I move on? How do you know it's on the same side as T? Here's T. This is the right. This is the left. 7 and 8 are both on the right of T. They're either both to the right or both to the left, or one's on the right and one's on the left. Last word. The only combination we haven't used is alternate exterior angles. So these are on different sides of T. Do you see this one? All right, angle 9 and 10 are on different sides. Angle 9 is on the left and angle 10 is on the right of T. And they're exterior. They're outside of lines S and R. Outside. Okay. Alternate exterior angles are as far away as you can get from each other. So it's like they had a big fight and they're like, I don't want to see you anymore. And they both walked in different directions. They're as far away as you could get alternate exterior angles. All right. Go to the back of your notes. Back of your notes. We're going to label some angles. Actually, you have a different one on the back, don't you? Do you have this one on the back or the one with just 3 lines? Okay, so I know you already know all the angles, so I'll go ahead and reveal all of these. It's not a surprise. I feel like Vanna White when you go and you press the letter and it disappears. All right, let's do the first one together. 1 and 15. 1 and 15. So you ask yourself some questions. Are those on the same side or alternate sides of the transversal? Here's the transversal. By the way, the transversal could change in every question. It might change every time. Those are on alternate sides. So we know to start with the word alternate. Then we ask ourselves, are those angles interior or exterior? Are they inside the lines or outside the lines? Yep, exterior. So 1 and 15 are alternate exterior angles. Let's do the next one together, and then I want you to fill the rest out on your own. 2 and 6. Now 2 and 6, you might want to turn your head sideways to look at that because our transversal is going sideways now, if that helps you. 2 and 6, are they on the same side or alternate sides? Well, 2 is above and 6 is below, so they're definitely alternate. And then, are they interior, inside, or exterior, outside? Oops, I put 2 eyes. They're alternate interior. They're between the 2 lines. Next one, 6 and 11. You should have gotten same side interior. 8 and 6 are corresponding. 9 and 11 are corresponding. 16 and 4 are none. That was a trick question. Trick question. 12 and 14 are vertical angles. And 3 and 13 are alternate exterior angles. Alternate exterior angles. That was same side interior angles. Did you get them right? How'd you do? Are none, because they're not even on the same transversal. They're not even on the same transversal. If they don't share a transversal, you can't use these vocab words. These words are for angles within the same transversal. Your homework tonight is just to practice naming angles. So please practice your homework over the weekend. It's not very long, and you're practicing the names because you have to get these names down. Have a great weekend.
Oh, that one works. Hey everybody, what's up? What's up? What's up, Albus?
I have to come turn my volume up because y'all are being so loud. I'm turning it off.